Lesson 2. Vectors in 3D. You can use 3D vectors to describe positions and displacements relative to the x, y, and z coordinate axes. You can represent them as column vectors or by using the univectors I, j, and k. I, in column vector notation, is 1, 0, 0, and is for the x-axis. J is equal to 0, 1, 0, and is the univector for the y-axis. And k is equal to 0, 0, 1, and is the univector for the z-axis. For a 3D vector, in ijk notation, pi plus qj plus rk is equal to the column vector pqr. Let's do some examples. The points A and B have coordinates 1, 5, negative 2, and 0, negative 3, 7 respectively. Part A, find the position vectors of A and B in ijk notation, and then part B, find the vector AB as a column vector. For part A, the vector OA will be 1 across in the x-axis, 5 across in the y-axis, and minus 2 in the z-axis. And so it will be I plus 5j minus 2k. OB will be none across in the x-axis, but minus 3 in the y and 7 in the z. So it will be minus 3j plus 7k. For part B, the vector AB will be equal to the vector OB, subtract the vector OA. In column notation, we can write this as 0, minus 3, 7, subtract 1, 5, minus 2, which gives us minus 1, minus 8, 9, and that is AB. You can find the angle between a vector and any of the coordinate axes by looking at the right angle triangles formed. If the vector A is equal to xi plus yj plus zk makes an angle theta x with a positive x-axis, then cos of theta x will be equal to the I component, the x component, x, over the length of A. And this will be similar for theta y and theta z. Let's do one more example. Let's find the angle that the vector A is equal to 2i minus 3j minus k makes with a positive y-axis. First, we need to find the length of A using the Pythagorean theorem, which will be the square root of 2 squared plus negative 3 squared plus negative 1 squared. And this will be equal to the square root of 4 plus 9 plus 1, which gives us the square root of 14. And we know that cos of theta y will be equal to y over the length of A, which is minus 3 over the square root of 14, which is around negative 0.8017, so on. And so therefore, theta y will be the inverse cos of this, which will give you around 143.3 degrees to 1 dp. And that's about it.